The shared responsibility model is the foundation of cloud security. The cloud provider secures the infrastructure. You secure what you put on it. Simple, right? Except it's not. Because in the real world, this model breaks down in 5 critical ways that cause security incidents, operational failures, and finger-pointing when things go wrong. These aren't edge cases. These are common, predictable problems that affect organizations of every size across every cloud platform. And if you're not actively managing these issues, they're already affecting your environment, whether you realize it or not. Today, we're exposing the 5 critical problems with cloud responsibility: gaps, overlap, ambiguity, drift, and limits. We'll show you what each one looks like, why it's dangerous, and most importantly, how to prevent it from causing disasters in your cloud environment. Because understanding where the shared responsibility model fails is just as important as understanding how it's supposed to work. Let's dive in. Responsibility gaps are the most dangerous problem in cloud security. This is when something critical falls between provider and customer responsibilities. Nobody is handling it because each side thinks the other one is. Here's a classic example. You're using a managed database service. The provider handles database engine patches, infrastructure maintenance, and automated backups. Great. But who's responsible for monitoring database query performance and identifying problematic queries that could crash the database? Who's ensuring your application isn't vulnerable to SQL injection, even though the database platform itself is secure? Who's testing that those automated backups can actually be restored? These are gaps. The provider gave you backup functionality, but testing restores is your job, except many organizations never do it because they assume the provider has it covered. The provider secures the platform from infrastructure vulnerabilities, but application layer attacks, like SQL injection, are your responsibility, except developers might assume platform security means they're protected. Responsibility gaps happen at the handoff points between provider and customer responsibilities. Network security is another example. The provider secures the physical network. You configure virtual network security groups. But who's monitoring for unusual traffic patterns that might indicate lateral movement? The provider generates the network flow logs, but if you're not actively analyzing them, there's a gap. Security incident response is particularly gap-prone. The provider has incident response for infrastructure failures. You need incident response for application-level issues. But what about a sophisticated attack that spans both layers? Who coordinates? Who has visibility into the full attack chain? Gaps are dangerous because they're invisible until something goes wrong. And when they're discovered, it's usually during an active incident when you desperately need someone to be handling the thing that nobody is. While gaps mean nobody's handling something critical, overlap means both parties are doing the same thing, creating duplicate effort, confusion, and often conflict. Monitoring is the classic overlapping responsibility. The provider monitors infrastructure health, performance, and availability. You need to monitor application performance, user experience, and business metrics. But there's overlap in the middle, system-level metrics like CPU usage, memory consumption, disk I/O. Both provider and customer might be collecting these metrics, setting up alerts, and responding to issues. This creates problems. You get alerts from the provider's monitoring and from your own monitoring about the same issue. Which do you trust? Which is more accurate? Who responds? The duplication wastes resources. You're paying for monitoring twice and creates confusion during incidents. Security scanning is another overlap zone. Cloud providers offer vulnerability scanning services, but security-conscious customers also deploy their own scanning tools. Now you have 2 systems scanning the same resources, generating overlapping findings, and someone has to reconcile the differences. Did the provider's scanner find something yours missed? Is your scanner generating false positives the provider's tool correctly ignores? Backup and disaster recovery often overlap too. The provider offers automated backup services, but many organizations implement their own additional backup solutions for extra protection or compliance reasons. Now you have 2 backup systems, 2 retention policies, 2 sets of restore procedures. During a disaster recovery scenario, which backups do you use? Have you tested both? Do they conflict? Overlap isn't always bad. Redundancy can be valuable, But unintentional overlap creates waste, confusion, and coordination problems that can actually make incidents worse instead of better. Ambiguity is when the responsibility boundary is unclear and both provider and customer genuinely don't know who should be handling something. This happens most often with newer or rapidly evolving cloud services. Consider serverless computing like AWS Lambda. Who's responsible for securing the function execution environment? The provider manages the underlying infrastructure and the Lambda service itself. But what about the runtime security? What about the dependencies your function uses? What about secrets management for credentials your function needs? The documentation might say shared responsibility, but that's not helpful when you need to know specifically who needs to take action. Is runtime patching the provider's job or yours? Different teams might interpret this differently, and neither might be wrong based on the available information. Container security is notoriously ambiguous. In a managed Kubernetes service like Amazon EKS, the provider manages the Kubernetes control plane. You manage the worker nodes and the containers. But who's responsible for ensuring container images don't have vulnerabilities? Who patches the base images? Who enforces pod security policies? The boundaries here are fuzzy, and different organizations interpret them differently. Third-party marketplace applications create ambiguity too. You deploy an application from the cloud provider's marketplace. The provider hosts the marketplace and ensures the deployment mechanism is secure. The third-party vendor created the application. You're using it. If there's a security vulnerability in the application, who's responsible? The vendor who wrote it? The provider who distributed it? You for choosing it. Ambiguity is dangerous because it leads to assumption failures. Everyone assumes someone else is handling it, or everyone assumes they're not responsible, and critical security controls simply don't get implemented. Responsibility drift is when the boundaries between provider and customer responsibilities shift over time, often without clear communication, causing confusion and security gaps. This happens as cloud services evolve. A service launches as IaaS, where you manage everything above the hypervisor. Then the provider adds managed features, automated patching, managed updates, built-in monitoring. Great, right? Except now, the responsibility boundary has shifted. Things you used to handle are now provider managed. But did your team get the memo? Are you still doing manual patching on a service that now patches itself, wasting effort? Or worse, did you stop doing something thinking the provider handles it, when actually you still need to enable and configure the new managed feature? AWS RDS is a good example. Initially, you were responsible for database backups, even though it was a managed service, you had to configure them. Over time, AWS added automatic backups with sensible defaults. The responsibility drifted from you must configure backups to backups happen automatically, but you should verify the settings. Teams that didn't notice might think backups are fully automatic when they still need configuration for retention, cross-region copies, and restore testing. Service deprecation causes drift too. A cloud provider announces they're retiring a service and migrating customers to a replacement. The new service has different security controls, different configuration options, and different responsibility boundaries. Teams migrate their workloads but don't update their security practices to match the new boundaries. Multi-cloud and hybrid cloud environments experience drift as different providers change their services at different paces. What was a consistent responsibility model across providers becomes inconsistent as each provider evolves their offerings independently. Drift is insidious because it happens gradually. There's no single moment when things break, just a slow erosion of clarity about who's handling what, until eventually an incident reveals that something critical stopped being handled months ago. Finally, let's talk about responsibility limits. Things that are technically someone's responsibility, but where that party has limited ability to actually fulfill the responsibility effectively. Customer responsibility for encryption key management is a perfect example. Major cloud providers say, you're responsible for managing your encryption keys, and that's true. But the practicality is challenging. Most organizations don't have the expertise to implement proper key management, rotation, access control, and auditing. They're responsible for it, but they're not equipped to do it well. The provider offers tools, but the customer lacks the knowledge to use them correctly. Provider responsibility for zero-day vulnerabilities in infrastructure shows limits from the other side. The provider is absolutely responsible for patching their infrastructure. But when a zero-day vulnerability is disclosed, a critical flaw with no patch available yet, the provider can't instantly fix it. They're responsible, but they're limited by the reality that software vulnerabilities take time to patch, test, and deploy. Customers are exposed during that window, and the provider can't eliminate the risk no matter how much they want to. Data residency compliance illustrates mutual limits. You're responsible for ensuring your data stays in approved geographic regions for compliance. The provider offers region selection and data residency controls. But if the provider has a catastrophic failure in your required region, they might fail over to another region to maintain service availability. They've broken your data residency requirement, but they did it to fulfill their availability commitment. Both responsibilities have limits. Security incident detection and response time has limits on both sides. The provider commits to detecting and responding to infrastructure-level incidents within certain timeframes. You're responsible for detecting and responding to application-level incidents. But sophisticated attacks that move slowly, that blend in with normal behavior, can take days or weeks to detect regardless of how good your monitoring is. The responsibility exists, but the capability has practical limits. So how do you prevent these 5 problems from causing disasters in your environment? For gaps, explicitly document responsibilities at a granular level. Don't just say, customer handles security in the cloud. List specific tasks, who monitors what, who patches what, who tests what. Look for handoff points between provider and customer, and ensure nothing is falling through. For overlap, coordinate intentionally. If you're implementing monitoring that overlaps with provider monitoring, document why and how they work together. Eliminate unintentional duplication, but preserve intentional redundancy where it adds value. For ambiguity, when documentation is unclear, ask. Cloud providers have support channels, architecture reviews, and well-architected framework assessments. Use them to clarify boundaries and document your interpretation so your whole team is aligned. For drift, stay informed about service changes, subscribe to provider change logs, review quarterly service updates, and periodically audit your understanding of responsibility boundaries against current documentation. Treat major service migrations as opportunities to reassess responsibilities. For limits, be realistic about capabilities. If you're responsible for something but lack the expertise, get training, hire expertise, or use managed services that reduce your responsibility burden. Recognize that some responsibilities come with inherent limitations and plan accordingly. Defense in depth, incident response plans, insurance. Most importantly, treat responsibility management as an ongoing process, not a one-time documentation exercise. These problems evolve as services change, as your usage changes, and as threats evolve. Regular reviews, clear communication, and honest assessment of capabilities are essential. The shared responsibility model is powerful, but it's not foolproof. Gaps, overlap, ambiguity, drift, and limits are real problems that affect every cloud deployment. Understanding these problems doesn't eliminate them, but it gives you the awareness to actively manage them instead of discovering them during incidents. And remember, knowing where the model breaks down is how you prevent it from breaking your security. See you in the next one.